Hello and welcome to this video on a weird genetic, archaeological, and historical phenomena known as the Y chromosome bottleneck. This phenomena is an example of the royal families, but on a species level. A less glib, it is an example of a sudden reduction in the population that we can measure in a manner of speaking. It is by the diversity of Y chromosome sources. In effect, for some reason, everybody's father seemed to go out to buy milk and cigarettes at the same time, leaving only a very few males behind to provide for future generations, and likely to experience death by snoo-snoo. Why we compare this to the royal families is simply that it is demonstrated through a drastic reduction in genetic diversity of humanity. Unlike the royal family, this is not due to something like a fratricide, patricide, matricide, marrying your cousin too many times, or just plain incest. It is instead likely due to something rather more major. Something like famine, disease, natural disasters, genocide, and similar large-scale events that kill indiscriminately over a very short period of time. A short period of time in relative terms here. As with any large-scale reduction in the population, we end up with something like the founder effect. For example, koalas have this, and as a result are very vulnerable to chlamydia. The horny little fuzbears are actually sexual degenerates and don't use protection. This does bring us to humanity. What we find is that it's an example of a reduction in the gene pool of a population, humanity in this case, and because of that, we have a carrying on effect from it. Mostly it's going to affect our genetic diversity and thereby limit how many different versions of genes or genes in general can be passed on to future generations. Because genetic diversity is low, and will only increase, at least to some extent, when new genes become present from another population, or, over time, due to random mutations in humanity, we see in this case, genes remain relatively stable. That is, it doesn't change over time. This should, if everything works well, lead to one of two outcomes, and, we say works well in a very liberal sense. As with all natural selection phenomena, if the population that has been affected by this isn't able to adapt or isn't suitable to its environment, you basically get selection against them. And because of that, they start dying off. This also has other effects in the meantime, generally in adverse mutations. For example, it led to humanity having furries. And things like cancer. But either way, it was generally a net negative. On the other side of the coin, we have if the population is well suited to the environment due to this population bottleneck. That is, they have a greatest or greater genetic fitness due to limitation. Generally speaking, the genes that are, let's say, more conducive to environmental survival or pressure survival will increase while the pool itself of different genes is reduced, because even if that's another gene and it's different, if it doesn't help you, it eventually dies off or gets pruned away through nature. Don't mention this to Tate or his ilk, as it seems like the sort of thing they jump on to justify their special kind of cultism. In practice, this all sounds horrifying, but it is based in something rather real, and that should make it more alarming to you. We have effectively two studies that have occurred over the last 20 or so years. One is from 2023, and that's a more recent study, looking at genetic, diversity amongst humans. Specifically looking at rather obviously the Y chromosome. And what they found was that there's a bottleneck of around 100,000 to 1,000 individuals somewhere around 900,000 to 800,000 years ago. Now, this lasted for a period of roughly 100,000 years plus or minus about 10,000. And because of this, it had two very immediate effects. One of which is it nearly killed off humanity by bringing us to extinction, and this may explain why we never encountered aliens before if they've had something similar. But the second is rather obviously that it created, a very confined gene pool. The second event was relatively more recent, at about 7,000 years ago, and this occurred over a period of about 2,000 years. Rather than comparing the human ancestor population, this is far more immediate, and it looks mostly across the continents of Africa, Asia, and Europe, and this does explain why humanity, despite being relatively different in culture and society, are all nearly identical in genetics, basically a 99.99% similarity, close enough that you could basically take one human and confuse them for another if you only had their genes to go by, most of the time anyway. This latter incidence, the 7,000 years ago, is where we look at the Neolithic Y chromosome bottleneck. So to be clear about it, we basically have two major events. The first was about 900,000 years ago to 800,000 years ago, and that's the 2023 study. And then we have the newer 7,000 year ago event, and that's from research in 2015. The 2015 research is rather more important to humanity at the moment than the older research but newer dated research is. The reason for that is very simple. If we go back roughly 7,000 years, so 5,000 BC or thereabouts, this is where we see the Y chromosome diversity drop suddenly, and by a significant degree. We mean, basically, there were two choices at that point. Humanity disappears, or we recover, but we have messed up genes. And humanity basically survives like cockroaches, so we went with the latter. What happened was that all the offspring, and the rather alarming ratio of men to women, was overcome. And we say offspring surviving because, well, first of all, there's a lot of men have died off, and the men survived despite snoosu because there was one male for every 17 females. Yeah. So it's very unlikely that anybody who had a, let's say, sibling at that point would have anything but a sibling in their relatively local area. It's important to note, though, that this research is, let's call it, theoretical in some respects. We do have genetic information to back it up, but most of it is based on simulations. Admittedly good simulations, but simulations. And it more or less involved a couple of undergrads looking at this and going, this is weird, let's explore it, and poking around with various computational models. They had 18 of these simulations in the end, and they included factors such as the Y chromosome mutating, competition between groups, death of individuals, and so on. Their conclusion is that the major reduction in the Y chromosome, or the cause of the Y chromosome bottleneck, was more or less that the clans, and specifically the patrilineal, that is the father's line clans, would have been involved in war, and that war would have killed off many of the males, leading fewer males to procreate. That by itself explains some of what we're seeing, but it does get more incestuous. We would say it can always get more incestuous, but that only goes so far before your mother, brother, sister, grandmother, daughter, something just becomes a splotch of ink rather than a family tree. In this case, though, rather than terrible jokes about inbreeding, we instead need to look at the fact that surviving clans would have all been closely related. Not so close as to be incestuous, but in terms of them having, if not the same, very similar Y chromosomes. So, if the surviving or victorious clan was able to continue living on, they would continue to spread the Y chromosome they had, whereas the loser would most likely have died off, and so that particular branch of the Y chromosome was gone forever. It is important for us to point out that although there is a Y chromosome bottleneck, there appears to be no such bottleneck in terms of the mitochondrial DNA, so there's no female equivalent that we're aware of at this point. There is arguably one easy explanation for this, and it's, strictly speaking, it tended to be that females would marry into a different clan from which they came. Essentially, patrilineal societies would have females come in, and therefore the mitochondrial DNA in their particular line would spread further and further, whereas males tended to stay within one clan, and therefore, once that clan was destroyed, that was the end of it. Due to the nature of warfare at this time, and basically how things worked, it was, if you're a male and you're not old enough to be, let's say, indoctrinated into the new clan's ways, you would die. If you're a child, you might wind up essentially becoming adopted in a very violent and unexpected manner, and if you were a female, well, you've now become someone's new wife, which also probably unexpected and violent. This is notably exacerbated by the nature of society at the time. We are talking, let's say, a few thousand years before the pyramids, although it depends on what pyramids we're talking about exactly, but let's assume Egyptian for now. If we're looking at roughly 2,000 to 2,500 years earlier than the Great Pyramids of Giza, society lived in much smaller groups. Therefore, it was all small-scale farming and more or less subsistence. That meant that societies didn't yet have the chance to grow and therefore diversify in terms of genetics. This was basically the gap, let's call it, between large-scale farming, using much more developed tools, societies, and so on, and not quite but very close to gatherer-hunter societies. The small size of these societies means that any changes to them, even within a single clan, could be quite telling and have long-term repercussions, let alone if we're looking at a much larger scale, like for example entire continents. And so, we need to note that this is before the start of large-scale societal organizations. Things are still small-scale, and therefore the effects of Y chromosome bottleneck will be felt much more. However, after all this, we need to keep in mind that there is, let's say, limited information, at least directly, from that time, so societies did vary notably. As a result, though, there could be, let's say, greater forces at play that aren't necessarily directly accounted for by their modelling. Let's call them explanations, and the various factors that have been adjusted for in the modelling of what's happened are reasonable, let's say, assumptions to make, or perhaps better to call them assertions at this point, and they do explain things quite well, but they're not necessarily a perfect explanation. There could be another, let's say, reason. Rather than warfare, it could have been famine, and for whatever reason, males more likely to die at that time. Or there could have been something like a particularly nasty predator going through and killing off male hunters. There are other ways you could look at this occurring, but whether we look at the mechanism or the outcome, well, the outcome doesn't change really. The mechanism may, but it's not so important. What does sort of conclude all of this is that it is why humans are all very much alike. Yes, there are differences in skin color, height, hair, and more, but the core is the same. The same bones, organs, tissues, muscles, requirements, and so on. Sure, there are adaptations in novel environments, but not drastically different to each other. Like with different races, it mostly makes little difference today. It could be useful in certain ways, such as understanding the spread of certain genes, pathologies, migration, and more over history, but ultimately it doesn't really alter the underlying factor that you could theoretically trace yourself back to a relatively small number of males that are the progenitors of just about every human in the world today. Whether that is 1,000 or 100,000 will be different, but it's still possible that you could be very, very closely related to each other, just a lot further back than you think. Thank you for watching this video, and if you happen to find it interesting, consider liking, sharing, subscribing. Please do post any comments, questions, or suggestions you have below.